All right, let's get started with three-dimensional figures, the first section of Chapter 12. Our lesson objectives are to classify solids, describe cross-sections, sketch and describe solids of revolution. And our essential question, what is the relationship between the numbers of vertices, V, edges, E, and faces, F, of a polyhedron? All right, to start, let's talk about how we classify our solids and some key vocabulary words. All right, a polyhedron, it's a solid that is bounded by polygons. Plural is polyhedra or polyhedrons. Our faces are the polygons that bound the polyhedron. Edges, they're the line segments formed by the intersection of two faces. And the vertex is the point where three or more edges meet on a polyhedron. So if you're looking at our image over here, this particular prism, it's a trapezoidal prism, has 1, 2, 3, 4, 5, 6 total faces making up the polyhedron. And edges is where two of the faces come together. So this is an edge, this is an edge, this is an edge, an edge. These are all edges where two faces come together and meet, they intersect. And a vertex is like the corner. It's the point where three faces come together and meet. All right, one of our core concepts is the types of solids. We've got polyhedras, and we have those that are not polyhedrons. They're still considered solids, though. A polyhedra is those that can be classified as prisms, pyramids, and then our cylinders, cones, and spheres are considered not to be polyhedral, even though they are still a solid. And that's because they have circular faces. Circles are not considered polygons. All right, to name your prisms and pyramids, the main difference is the number of bases. So prisms have 2 bases, pyramids have 1 base. And make sure you identify your bases correctly. For the examples we have here are prisms. This one's considered a pentagonal prism because the 2 bases, the one that are parallel, the bases are always parallel to each other. And they're always a matching shape that are parallel. So this shape is a pentagon, and because it has 2 bases, it's a prism. So put that together and it's a pentagonal prism. This one's a triangular prism because its bases are triangles. Notice the lateral faces are rectangular, same with our pentagonal prism. And then our trapezoidal prism also has 2 bases that are parallel that are trapezoids. And then our pyramid has just a singular base, and the other faces are always triangles. And you name a pyramid by the shape of its base. So for this one, the base is a triangle, so it's a triangular pyramid. For this one, the shape is the base is a pentagon, so it's a pentagonal pyramid. And for this one, the base is a square, so it's a square pyramid. All right, so let's take a look and try the example A, B, and C. Tell whether each solid is a polyhedron. If it is, name the polyhedron. All right, so sample A looks like it has all faces that are polygons. Therefore, we can say, yes, this is a polyhedron. And then we would name according to its bases. And it looks like there are 2 of the same bases that are parallel. Therefore, it must be it looks like opposite sides are congruent, but not all 4 sides. So this looks like a rectangular prism. All right, the next example, B, has 1 base, and the rest of the faces are triangular, but they are all polygons. So we can say, yes, it is a polyhedron, and then classify it as let's see, how many sides? It has 1, 2, 3, 4, 5, 6 sides for the base, so that's a hexagonal pyramid. And then the last one, sample C, has a circular base, so therefore it is not a polyhedron because circles are not polygons. All right, so our next topic is describing cross-sections. First of all, cross-section is the intersection of the plane and the solid. So you can see by this first image, our solid is the blue portion of the figure, and it looks like a cube. And then the light-colored flat surface that is passing through the solid, and the intersection is the purple portion. And this square looks like the cross-section is in the shape of a square. In other words, if you were to pull apart the cube and look at it from an aerial perspective, you could see the shape of a square. For the cube, the plane to pass through the cube diagonally, the cross-section forms a rectangular shape. And then for the plane to kind of pass through just the corner piece of the cube creates a triangular cross-section. All right, so let's take a look at these examples and try to practice describing cross-sections for the solids that the plane passes through. So let's look at example A. It's a 6-sided, two bases, so it's a hexagonal prism. And the plane's going vertical through the prism. So the cross-section is the shape of a hexagon. All right, next we have a pyramid, and looks like the base is the shape of a triangle, and the cross-section is going horizontal through the pyramid, so the cross-section would be triangular. All right, and then next we have a cylinder with a vertical plane passing through, creating cross-section that looks rectangular. And for D, we have a cone being intersected by a plane, so our cross-section looks circular. Let's see, example E has a sphere with a cross-section that looks circular as well. Then our last example is looks like a cube, and our plane's kind of going at sort of at an angle, and so therefore our cross-section appears to be a trapezoid. All right, so that's describing your cross-section. It's when a plane intersects a solid, and it can be at any angle. The plane can intersect at any angle. All right, our next concept is sketching and describing solids of a revolution. A solid of a revolution is when three-dimensional figure that is formed by rotating a two-dimensional shape around an axis. And then our axis of revolution, it's the line around which the shape is rotated. So think of this as a progression. This is what you start off with. Here's your axis of revolution. And as you rotate the shape, which this shape appears to be a rectangle, as you start to rotate the shape, you start to see how it forms a cylinder. So our solid of revolution of a rectangle creates a solid that is a cylinder. All right, so sketch and describe solids of revolution. So sketch a solid produced by rotating the figure around the given axis. Then identify and describe the solid. So for example A, we have a rectangle that has a 9x4 dimensions. So describe and sketch the solid that would be created from rotating this particular rectangle about this axis of revolution. And you would create a solid that is a cylinder. And the cylinder would have a height of 9 and a radius of 4. So just creating something like a cylinder around the axis of revolution. All right, and then example B looks like a triangle attached to our axis of revolution with a height of 5 and a length of 2. So if we were to rotate the shape around the axis of symmetry, what kind of solid would we form is the question. And the solid would most definitely be a cone. And the cone's height would have a length of 5, and the base would have a radius of 2. Now I want you to try all of these, 1 through 9. Shouldn't take you too long, just based on the notes that you took. See if you understand all the key vocabulary. This is a great opportunity to just kind of review over the key vocabulary from this first unit, as it will set you up for the entire unit. So pause the video here and answer all 9 of these problems, and then unpause to reveal the answers. All right, let's see how you did. All right, so there's your answers for 1 through 9, and then 7, 8, and 9 had sketches to include, so let's see how you did with the sketches as well. All right, bring your clarifying questions to class tomorrow.